Hello everyone, and welcome back to the Kohi Game Engine series. Today we're going to tackle a resource system. I would like to take a quick second and thank the supporters of the channel, beginning with our partners, Eearslya, Wensheng, and Caden. They are the partners of the channel, which is the highest tier of support for the channel, so thank you very much for that. And I would also like to thank all the other supporters listed here on the screen. Your support is very much appreciated, so thank you for that. Today we're going to tackle a resource system because I've decided that we've got several places where we're making some assumptions about file paths, and we've got some hard-coded paths in there and making some assumptions about where things are located, and it's just not very configurable or robust, right? And the other thing that we have is we have this sort of clunky post-build process that temporarily was copying assets to the bin assets folder, and that's kind of crappy too. So we're going to go ahead and knock that out today. And so what we're going to do is we're going to set up a new system that we're going to call our resource system. And the resource system is going to have a configurable base path, so we can point it to anywhere on the machine. In this case, we're going to point it to our assets folder in the main project, right? So instead of bin assets, we're not going to use that anymore. We're going to point it to this folder, right? And so one of the first things we're going to need to do is to edit this post-build bat file and sh file, right? And so first off, where we're going to run it from is not going to change. So basically, this here can go away because we don't need to create the bin asset shaders anymore. And when we compile our shaders, instead of going from assets, shaders, whatever, to bin asset shaders, we're just going to plop it in the same folder, right? So all we're going to do is delete the bin from the second argument here. And we're going to come down here and do the same thing, okay? And then we're going to completely get rid of this copying assets, okay? Because we don't want to do that anymore. All right, I'm just going to do the same thing in the bash script. So I'm going to remove this bin here. I'm going to remove these make directories because we don't need those anymore. Remove this bin, and this one, as well as our copy assets, right? So now the only thing this does is compile our shaders. And we still need to come back and make this a little bit more robust, but I actually have different ideas on how I want to do this. So that is it for that. Now, if we were to run this, right? In fact, let me go ahead and just do that, right? So post build, okay? We see here that we now have our assets in the correct place. So under our assets folder, we now have these SPV files, right? But I actually don't want to include these in the Git repository. So I'm actually going to go ahead and Gitignore those. So I'm just going to come here to my Gitignore, and I'm going to go ahead and add a new line to ignore the SPV files. And we know that that is working by seeing that these are grayed out, okay? I'm also going to go ahead and delete this assets folder under the bin. We don't need that anymore, okay? Now we're actually ready to go ahead and create our system. Okay, so I'm going to minimize a couple of these things here. And the first thing that I'm going to do is I'm going to go ahead and create the resource system itself. So I'm going to come down here to systems and create a new file, call it resource-system.h. And I'm going to snag in a few things. Let me get rid of this. Okay, so obviously we want to include our resource types, and we want to include our resource system config, which we have something called max loader count, and we have the asset base path. Okay, so this is going to be a relative base path for assets, and technically speaking this could be an absolute path, but we don't want to deal ever with absolute paths. So we're just going to use this, we're going to configure this rather to be relative. Okay. Now, this max loader count, what do we mean when we talk about loaders? So the way that this system is going to work is each type of resource that we have in the system is going to have its own dedicated loader for that type, okay? And when I say type, I mean the type of file that we're going to load and the type of data that we're going to extract from that file. So for example, we're going to have one resource loader that loads image files, and that will essentially wrap our STB image, okay? And of course, convert it into the format that we need. We're going to have our loader for our material files to load our KMT files. We'll also make some basic loaders for text files and binary files, right? And so for every new type of resource that we add, we're going to add a loader for it, right? And so this max loader count is how many loaders can we have in the system. And I'm going to default that to 32. For now, we can always expand it because, again, it's configurable, right? That's the whole goal here. Before we can get into resource loaders, though, we need to have a concept of resource types, right? So we have our literal types here, right? So we have our material, we have our geometry, we have our texture map, and that's all well and good, but it doesn't really give us a sort of type system that we can work with for resources, okay? And so what we're going to do is we're going to have a concept of some predefined resource types, and some of them here I've already mentioned, right? So we have one for text files to load in just straight text from a file. We have a binary one. We have image. We have material. We'll have static mesh, which I mentioned before. That's coming soon. And then we have custom, and we're going to add to this list. But basically, we're going to have predefined types that are provided with the engine, and then we're going to have the ability for the user to add a resource loader of their own under type custom. And that will actually be string-based. So now that we have that, we need another type to represent a resource itself. And the way that this is going to work is each of these loaders is going to have an internal ID that's used for quick lookups. We're going to have the name of the resource. We're going to keep a copy of the full path. And then we are going to keep a pointer to the resource data itself. And this will vary per resource, right? And then, of course, the size of this data to go along with that. And the way that this is going to work is technically the resource loader is going to at least temporarily dynamically allocate this memory, and it'll also be responsible for releasing it. So when loading a texture, for example, you will load up an image resource, load up the data from that texture, upload it to the GPU rather, and then once that's done, you'll go ahead and release the resource, which will release any allocated memory, okay? And that's going to be the basic flow for all resources, okay? So with that, we're also going to have resource data types for at least some of these resources. So the first one that we're going to have here is an image resource data, which just holds channel count, width, height, and pixels, right? And so we're going to use this in our textures, right? And next, we're actually going to take our material config from our material system, because this is actually going to be our resource data for materials. So I'm going to actually just snip this out of here and put it in resource types. So we'll put that right above material, okay? Actually, it needs to be below this define here. All right. And so now we have our, at least our basic types defined, right? For text, we're just going to allocate a character array for this data. And for binary, we're going to allocate an array of unsigned 8-bit integers, okay? And so we'll just use this directly instead of using a source for those two types, all right? Okay, so back to our resource system. Now that we have a concept of resource types, now we're going to define basically an interface for a resource loader, okay? And this is going to have that internal ID that the resource has mapped to it. It's going to have a resource type. It's going to have a string custom type. And so if resource type here is set to resource type custom, then we can provide a string. I should say the user can provide a string. And this will be sort of a secondary lookup that we can do. And this is for custom resource types that are not provided with the engine, okay? So we're probably not going to wind up using this for a long time, if at all, but I wanted to be able to make this extensible so that users of the engine aren't going in there and modifying this enumeration. Okay. Next, we're going to have a type path. And so this is a sort of base path for the given type of resource. And so, for example, materials will be loaded in a materials folder, and textures will be loaded in a textures folder. And this will be appended after the asset base path to build out the path to that particular resource. Okay. So if we have a type that doesn't need that, we just provide an empty string. And then we have function pointers to load and unload resources, right? And at least this is our structure for now. It basically takes a pointer to the loader itself, the name of the resource to be loaded, and then a pointer to hold the resource that's been loaded. Okay, and then unload is pretty self-explanatory. It just takes a pointer to the resource loader, and then a pointer to the resource to be unloaded. Okay. And more than likely, we're probably going to have to extend this a bit to make it a little bit more configurable. But for now, I just want to keep things simple. Okay, so that's our resource loader structure. So next, we have our initialize and shutdown. Nothing really to explain there. Next, we have an exported function, which is our resource system register loader. So this is how we actually tell the resource system about our loader, right? So we create a loader and pass it in here. And this is passed by value, not by reference, on purpose, because we don't want to have something else own this object, right? We just are going to go ahead and just make a copy of this, and that'll be fine. So next, we have two functions. We have one that's going to be used by the system, the engine itself, which is a resource system load. And all this does is takes in a name, a resource type, and then the out resource, right? So this is a pointer to the resource to be loaded. And then we have resource system load custom, which takes the name, the string custom type instead of the resource type, and a pointer to the resource. So this is the one that's going to be used by the engine. This is the one that will be used by user code. Okay. Next, we have an unload, which just takes a pointer to the resource to be unloaded. And finally, we have a resource system base path, just in case we need to get that for some reason. It just returns this, okay? And that is it as far as our interface goes. So next, we'll go ahead and create resource system.c, and of course include resource system, our logger, and our string library. We'll go ahead and set up our system state, which is going to hold a copy of the config and then an array of registered loaders. Okay. Obviously, we'll need our state pointer. Next, we're going to forward declare a load function that takes the name of a resource to be loaded, a pointer to the loader that is going to be used to load it, and then out a pointer to the resource to be loaded. Right. So basically, the way this is going to work is the user is going to call this or this. These functions are going to pick the loader, and then they're going to call load, and that's actually going to do the work. Okay. Resource system initialize is pretty straightforward. Obviously, we make sure the max loader count is greater than 0. We go ahead and figure out our memory requirements. Later on, we set up our pointers, set up our array, go ahead and invalidate all the loaders by setting their ID to invalid ID. This is all stuff you guys have seen before. So I'm not really going to go into it any further than that. The only thing that we do differently here is we say resource system initialize with base path and spit that out to the console just for debugging purposes. All right, resource system shutdown doesn't really do anything for right now because there's not really anything that we need to sort of release. If we ever change this to use an allocator, that's where we'd release the memory there. But for now, we're not going to do that. So next we have our register loader. And all this basically does is make sure that we have a state pointer first off. If we don't have that, we boot out. And report a failure for this. We get a count of the maximum loaders, and then we go through and we look at all of the loaders that currently exist. And if their ID is not invalid ID, then we check the type to make sure that the type doesn't already exist, right? So we check that against the type, and then we check that against the custom type. And this is to prevent having a loader or multiple loaders for the same given type, right? We only want one loader per type. So this just ensures that. And then here we go ahead and find the first free slot and register the loader to that slot just by copying it over, okay? Pretty straightforward stuff, I think. Next, we have the resource system load. So this is the one that the engine uses. So all this does is make sure that the type is not resource custom. If it is resource custom, then we actually do not want to use this function for it. So we're gonna mark that as a failure and bleat about it, right? We're just gonna say no loader for the type was found, okay? Otherwise, we loop through and we compare the ID to make sure that it's not invalid and that the type matches. And then we return our load function up here. So the results of this guy, okay? The load custom works in a very similar manner. It's pretty much the same thing as up here. The only difference is it makes sure that the resource type on the loader is set to custom, and then it goes ahead and does a string case insensitive comparison. If it finds the loader, it returns the result of load. Otherwise, it bleats about it and boots out false. Okay. Unload is really straightforward. So all it does is checks that the resource exists, makes sure that the resource ID is not invalid ID, and then goes ahead and gets the resource loader at that index and calls its unload. Okay. Last of the public functions, we have our resource system-based path, which gets the asset-based path if the state pointer exists. Otherwise, it bleats about it and returns an empty string. And finally, we have our load function, which is actually pretty straightforward as well. So this just makes sure that we have a name, a loader load method, right, that function pointer has been assigned, and it makes sure that we have an out resource. If any of these are missing, it goes ahead and sets the out resource loader ID to invalid ID, and then returns false. Otherwise, it goes ahead and sets the loader ID to the found loader ID that's passed in here, and then returns the result of the loader load function, right? Passing along loader name and out resource, okay? And that is it for our resource system. It's actually really simple. Okay, so now that we have our resource system, we actually need to go ahead and create our loaders themselves. So our loaders we're actually gonna put under resources, okay? So we're gonna create a new folder, call it loaders, and I'm gonna go through and actually create 4 loaders today, okay? And so I'll walk through in detail sort of the first one and maybe the second one, and then the third and fourth I'm just going to kind of breeze over for time's sake, okay? So the first one that I'm going to create, I think, is going to be the image loader. So I'm going to create a new file, call it imageloader.h, and here we have a pragma once. We include the resource system because we need this resource loader structure. Notice that we're not returning a pointer here, right? We're just returning a flat one of these. And then we have image resource loader create. And this is basically all that is going to be publicly exposed about each loader, right? We're just going to have a create method that returns a resource loader. And this method is going to be responsible for setting up all the function pointers and things of that nature, okay? So let's go ahead and create our C file. All right, and our C file is going to include a number of things. So obviously the H file itself for the image loader, we're going to have the logger, memory, our string, our resource types, and our resource system includes, right? Just to make sure that we have everything we need. And in this case, we're actually going to be ripping out some of our texture logic, right? And so right now our texture system is actually using this STB. So I'm actually going to snip that out of here and now move it to where it should be in the image loader, okay? And this is what actually should be using that. All right, and I'm gonna go ahead and create this private method first called image loader load, okay? And this matches the load signature here. Okay, so this is the load function for the image loader, okay? And all this is going to do is basically take the, well, first it's going to validate that we haven't passed null pointers for any of this. And then it's going to go ahead and, I'm actually just going to paste this all in one shot. It's going to go ahead and create our format string for our full file path. So this is actually the same code that is in the texture system right now. So I'm going to go ahead and snip that out afterwards. So we go ahead and set our STB flip vertically on load to true. We use a format string here that is a little bit different than what's in the texture system. So we have our asset base path here. Then we have the loader base path, and then we have the file name and the extension. And we've just gone ahead and put the dot here instead of in the format string, because eventually when we go to try different extensions, we want the ability to actually pass the extension here in some cases. So we've gone ahead and removed the dot here, and we're just going to use it in the extension. And that way, if you pass, if you don't pass an extension, we'll just go ahead and use that one, right? We don't have that logic in here yet, but that's the general idea. Okay, and most of this logic is exactly the same as what you've seen pretty much before, okay? Okay, so once we've loaded up the image, right, we go ahead and set up our out resource, right? So first thing we do is we call string duplicate on full file path so that we get a copy of this string. So that way, since this is locally scoped, this is going to be destroyed when we leave the function. We don't want that. So we're going to string duplicate, which does allocate memory. So we probably should be using an allocator here. I'm going to put to-dos for now. This one as well. So we go ahead and create the resource data by dynamically allocating. Again, I put a to-do here so that we don't forget this. We should be using an allocator to do this, but for right now, to keep things simple, I'm going to do this instead. And then we copy over the pixels, width, and height that are output by stbi load. And the channel count we set for now to required channel count. We then set the resource data to out resource data. The out resource data size is just the size of image resource data. And then we go ahead and set the name, right? And this data size, incidentally, in this case, is used to free data, okay? All right, so now that we have that, we can go ahead and do our unload. So our unload basically just undoes this, right? It's pretty straightforward stuff. Obviously, it makes sure that we have pointers. It goes ahead and gets the length of the full path string, and then uses that length to actually free it, right? So we just free it using this memory tag string, which is the same tag that string duplicate uses to allocate that memory. So all we do is to take the size of character path length +1 for the null terminator and free that. And then if our resource data exists, we go ahead and free that using the data size, right? And we just do that under memory tag texture. Not the greatest of memory tags. We might want to have a separate one for images, but for now I'm okay with leaving it. We just zero everything out, and then that is it, right? And so our last function is the only public one, which is image resource loader create. This creates a loader, sets the type to the image type. Our custom type is just 0. We don't need that, so we're not going to set it. We just point our load and unload functions to our private functions here respectively. Our type path is going to be textures, and then we're just going to return the loader, right? And that is it for the image loader, okay? So over here in resource system, what we're now going to do is we're going to set up a little area for our known resource loaders. And the first one we're going to feed it is an include for image loader, okay? And now all that we have to do is come down here to where we have our note to auto register known loader types and call resource system register loader and feed to that the return result of image resource loader create, okay? And that is all there is to creating a loader, right? So now that we've done this loader, we actually need to go to the texture system and set that up to actually use our loader, okay? So this just requires a few small changes to the C file. We already removed the STB references, right? However, we do need our resource system to be included, okay? And then all the way down in load texture, which is here, we are going to change this up quite a bit, right? So we're actually going to get rid of all of this and replace it instead with a call to our resource loader, right? So we call resource system load, pass the texture name, tell it we want an image, and then the address of our image resource. If that fails, we delete about it and return false. Then we go ahead and cold cast the image resource.data to our image resource data type. Okay, and here we go ahead and get rid of the STBI load because we don't need that, and instead we set the properties directly using the result of our resource data. Okay, so we just set those. So next we remove this if data check because we don't need that. We can also get rid of all of this code down here. All right. And now we have our total size. We should be, instead of required channel count, we're actually just going to use the temp texture channel count here and here. Okay. And then here, instead of looping through data, we are going to loop through resource data pixels. And the rest of this is pretty much going to be the same. So obviously we don't need to be checking for STBI failure reasons, so we don't need that there anymore either. We still want to take a copy of the name, the texture generation and transparency code we want to keep the same. The renderer create texture, we're going to pass through this pixels array instead of data. So we go ahead and do that. And then for our cleanup data, we are going to get rid of the STBI image free and just replace it with resource system unload. Okay. And it looks like I actually messed up and removed the wrong bracket there. So let me go ahead and fix that. And I think we're good. Okay. So that is that. That is our first loader implemented and used within the system. Okay. So now I suppose it kind of makes sense for us to go ahead and go to our application and include our resource system, right? So we'll go here and we'll just make the changes that we need to make here so that we don't have to worry about this later. So we'll include our resource system and we're going to instantiate our resource system immediately after the platform. So that's where we're going to put this in here. Okay. And then we'll go ahead and set up our resource system under application create right after our platform and before our renderer system, because our renderer system is actually going to need this. And our configuration is going to look like this. So we're going to say go up one directory and we want the assets folder for our asset base path. And then the max loader count, we're going to default to 32. Again, that's configurable, so we can always change it if we need to. And then it's a standard, get the memory requirement, set up the state, make sure it initializes, blah, 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 blah. Of course, since we have that, we should also shut it down. So even though it doesn't really do anything, we should still be diligent and do it anyway. So we'll go ahead and call shutdown on that. Okay, and that is all we need to do at the application layer to get that registered and set up. Okay, so the majority of the rest of the changes that we have are all going to be loaders and then the things that use those loaders. All right, so let's go ahead and just build this real quick because I see that we have an error here and I just want to make sure that that is legit because I don't think it is. Okay, so I'm not sure completely why this is bleating about that, because that is it's saying there's too many arguments in the call, but clearly it does support 2 arguments. So I don't know why that's complaining about that. But anyway, The next thing that I actually want to do before we create our next loader is we actually need to make a couple changes to our file system. And this is going to be just to make this particular function work a little bit better. And we're actually going to add a function as well. So actually, let's add the new function first. So right below file system close, we're going to add a function just to get the file system size without actually doing anything else with the file. So all this does is just takes a file handle and returns true if it was actually able to obtain it, false otherwise. And then we go ahead and set the out size here, okay? And then our read all bytes actually is performing a allocation internally to out bytes. And I'm not a huge fan of this double pointer either. So I'm actually going to change the way that this works. And so instead of it allocating, we are just going to rely on the caller to allocate whatever memory is needed, which is why we wanted our file size above. So we basically get the file size and then allocate enough memory for that, and then we'll call this U8 out bytes here, and that will actually be set to the data, okay? So it's a small change. We change from a double pointer to a single pointer here, and then we just change this to out bytes read and change the comment a little bit. We also are going to add another new function because this is sort of a binary read, and we also want a text read to do the same thing but return or set a character array. So this does the exact same thing, just deals with characters instead. And you'll actually see the code looks remarkably similar under the hood. So in our file system.c, under file system close, we're going to put the definition for file system size. All this does is seek to the end of the file, set the out size to where that file pointer currently is. Then we rewind to the beginning of the file and return true, right? And that's all this does. It's pretty straightforward. So file system read all bytes is now going to be simpler because it's not going to perform this allocation anymore and not going to deal with a double pointer here. So I'm just going to replace that. And all this does is first grabs the file size, which I suppose we don't technically have to do here. We do use that for comparison here. So actually, we probably could just, call, in fact, I'm actually going to do that. I'm going to change this. Okay, so here we're just going to use our file system size to get this file size instead of doing it the old way. We might as well use that. And then we go ahead and read the bytes as normal, okay? So now that we have that, right below this, we have pretty much the same thing with our read all text. So all it does is use a character array instead of a U8 array, okay? And that is all we need to do for the file system, okay? All right, so the next thing that we're gonna do is we're actually going to create our material loader next. So under loaders, we're gonna create a material loader.h. And just like the image loader, it's going to be really simple on the surface. All we're going to have is a material resource loader create. Next, we'll create our C file. And our C file is going to look very similar to what we did for the texture, right? So this time, instead of the STB stuff, obviously we're going to use the file system. Okay? And this is where we're going to use our first new method. So we need our load function to be set up first. So here's our material loader load. And this function is almost exactly the same as what we're actually doing in the material system now. So what I'm going to do is I'm actually just going to plop the whole thing in here and sort of go over the relevant different parts, right? Because we don't really need to review all this logic. So as before, the format string is a little bit different. It just, instead of putting the dot here, we put it here. So that is different. We take a copy of the full file path. We open the file here. So we go ahead and allocate our resource data. So we set up some defaults in our resource data here, right? So instead of doing them below, we set those defaults here. We go ahead and take a copy of the name. Then we go through our line by line and process. Down here, instead of using defaults, we just don't do anything, right? We just say If we have an issue parsing the color, for example, it was already assigned above, so we don't need to have it here. This also allows us to handle if any of these fields are missing but required, we now have defaults for them, okay? So there's that. After we've closed the handle, we go ahead and set the data size, and the name and return, right? Unload will look pretty much exactly like it does for textures, right? So here we release our path and we release our data, right? Pretty straightforward stuff. Finally, the loader create just sets the proper load type, sets up the function pointers, and puts our type path to materials, okay? And that's it for that. That is our material loader. It is pretty straightforward stuff. So now we need to go back to our resource system, and we'll go to the top here and include our material loader, and then we'll go down here and register it, and that's it. Our material loader is now registered, okay? The only other thing that we need to do is we need to go into the material system itself, into the C file. So we'll go, and we just need to make a few small changes to use that instead of the file system, which will allow us to get rid of this to do, right? So the first thing that we're going to do is replace that with our resource system. And we actually no longer are going to need this load configuration file. So we can go ahead and get rid of that. And we'll do the same down below. And our initialize is pretty much the same. Our shutdown is the same. Our acquire changes a little bit. So I'm just going to paste in the new version of this, okay? So the first thing it's going to do is it's going to load the resource, right? And if that fails for any reason, we return a null pointer and bleed about it. Once we have the material resource with the configuration in it, we go ahead and acquire that from configuration. And then we go ahead and unload the resource to clean up any memory. And then we check to make sure that that material was actually loaded. And if not, we actually spit out an error and just return. And in this case, it's okay to return a null pointer, and we can handle that on anything that needs it. We may come back and want to change this to use the default instead, but for now we're not going to do that. Okay. So that is that. And the only other thing that we have to do is come down here and remove the now dead code from load configuration file, because we actually do not need this method in its entirety, right? So we can just completely snip that out of here. And now that is using our resource loader, okay? So that's materials done. So next, we're going to create another loader, and this is going to be for binary files, and we're going to use this one right away too. So we're going to call this binary loader. That's going to have a method to create the loader, create our C file, and again, our include should look pretty familiar at this point. The only difference is this one. All right. First, we're going to set up our load function, which I'm actually this time just going to paste in here in its entirety. Let me get rid of this because there's not too much to it, right? So obviously, we make sure we have our pointers. Again, our format string. This is all the same stuff. We take a copy of the full path. Here, we open a file in read mode, and we are reading binary, right? If we have an error with that, we go ahead and bleat about it, return false to indicate failure. We go ahead and get the file system size, okay? And if for some reason that fails, then we try to close the file and return false. We go ahead and allocate the memory for that, right? And this is a U8 array, right? Again, we should be using an allocator for this. But in this case, it's fine that we're not. We'll mark it with a to-do for now. And then we go ahead and call our new newly refactored read all bytes. If that fails, then we close the file, bleat about it, and return. Otherwise, we close the file, set our data size and name, and we're good to go, right? Unload shouldn't even really need too much explanation. We just free the full path and free the resource data, okay? And then, of course, our create function itself also doesn't require any additional explanation. We just set the type, function pointers, and in this case, we actually return a type path of blank because these binary files can be loaded from anywhere. So we don't want to restrict it to a specific folder. So in this case, whenever you're loading a binary file, you should also provide the full path to the file that you're going to be loading, right? You'll note also here that we do not provide an extension, right? And so that's the reason that we set this up this way, is because we can actually just pass the entire path as name. Okay. All right, so that is that. We need to now go to our resource system C file, and we need to include our new loader. And I'm actually going to include these in the order that they're declared in our resource types, right? So we have material last, image binary, and then text is first. So I'm going to import these, and I'm going to include these in the same order, and I'm going to register them in the same order. Okay. So we have our binary, which now goes at the top here. All right. And now that is set up. Now, as for what actually uses this, something that you may have forgotten about at this point is our shader utils actually uses a binary file read. So we are going to modify our shader utils to use our resource system instead. So we're going to get rid of this file system and use our resource system instead. And we're going to replace this build the file name here with, which will also be used as the resource name. Okay. And we're going to go ahead and change the string format to be a little bit different. Okay, instead of assets shaders, we're just going to use shaders, right? So this will be name type string SPV. Okay, and of course that will be the whole file path that we pass through to the resource loader. So here we want to go ahead and load the resource. Instead of retaining a file handle, we'll go ahead and read the resource. Okay, and of course that just passes through the file name that we built up here. All right, obviously if that fails, we'll just return the same error message as before. So the next thing we'll do is we'll go ahead and get rid of this read the resource because we don't need that. Whoops. So the next thing we'll need to do is get rid of this block because we're not doing that anymore. And we're going to go ahead and we're going to get rid of these as well. Okay. And we're also going to get rid of this file system close. Okay. And instead, what we're going to do is we are going to, you know what, in fact, let's move this up here. Okay. So now we have our 0 memory. We're going to set the code size and P code to use the data that's passed in as from the binary resource. Okay. And then after we create the shader module, we'll go ahead and clean up, okay, by releasing the resource. And that should be all that we actually need to do here, right? So it's pretty straightforward stuff. So at this point, we should be able to go ahead and build. And if you recall, in our bin folder, we've already deleted the assets folder, so we shouldn't need that anymore. We should be able to go ahead and run. And you'll note that the application still works as designed, right? So this is now using a proper resource system that is configurable, and this is going to be a lot more flexible and easy to use, right? And so with that, one more thing I'm going to do is we have one more loader that I want to create that we're not using right now, but we eventually will want to have it, and that is the text loader. Okay, so I'm going to create one more loader. Okay, and that's going to be text loader.h. Here we are going to create our basic header file. We're going to create a text loader.c. Same includes as usual. Pretty straightforward stuff, and this is actually going to look remarkably similar to the binary loader. The main difference with this is in our text loader load, instead of reading the file as binary, we are going to read it in non-binary mode or text mode. Okay, and otherwise this logic here is pretty much identical other than the call to read all text. Okay, and our resource data is going to be of type character array instead of a U8 array. Okay, but other than that, it's pretty much the same. Our unloader is the same as well, only it's dealing with a different type of data. So it's again pretty much the same thing, and our create function is also pretty much the same. just with a different type and different function pointers, right? Again, we have no pre-configured path on this because we can load this from any folder. Okay. So in our resource system, let's go ahead and perform our final registration, at least for now. We want to put this at the top because the text loader comes first in our order of loaders. And then we'll go ahead and register the text loader here. All right, and we're going to go ahead and build just to make sure that everything is good. And run. No errors. We can move around freely. Our textures still load, right? So everything here works as we expect. And yeah, so that is basically it for this video, right? We have a new resource system that we can use to properly load resources and not have to worry about file access, right? And that means that we can change the way that that file access works in the future and not have to actually worry about it by the things that are consuming the data in those files, right? So anyways, that's going to wrap it up for this video. Thank you guys so much for watching. If you liked the video, please toss it a thumbs up. If you haven't already, consider subscribing. Click the little bell icon there to get a notification as to when the next video in this or other series drops, and I will see you guys next time.